Okay, so if I've done my job, then you're looking at a scene that is pulled in from Blender through gltf into Bevy, and we are using custom properties inside of Blender to drive gltf extras in the gltf export to control which colliders in this scene are actually active. The reason we're doing this is that other options, including things like searching for the names of objects that you've spawned in a scene and then attaching colliders or attaching different components to them, is kind of error prone in the sense that if you change the name inside of Blender, re-export it through gltf, you could be targeting something that you didn't expect to be, etc. So it's nice to have some structured data of some kind that we can specify in Blender and then rely on and be able to deserialize inside of Bevy and apply components. So we're going to build up this example from scratch. I'm going to create a new folder and I'll link the GitHub repo in the description. I'm going to call this YT or YouTube Blender Bevy gltf extras custom properties. Pretty verbose name, I know, but the name isn't that important for us. So we're going to need Bevy. We're going to use Avian for the colliders. And we're going to cover where to get this information, what we're actually doing here, how to look stuff up, etc. So don't worry about it. Of course, I do need to type the right command to add these. So I'm going to do cargo add, and that's going to drop Avian 3D and Bevy into our cargo.toml here. We're going to pull the Bevy prelude in, do app, new, add the default plugins, and then just run it. We don't really have anything to do just yet. We just want to make sure that we can actually run our application. So we've got our Bevy app running, all well and good. Wonderful. Now, basically everything we're going to do for this project is going to be done inside of Blender, except for the code that, spawns everything, etc. But all of our level setup, all of our scene setup is going to be done in Blender. So this is just called scene right now, but I'm going to call this like level 1, let's call it. And I don't really need the camera or anything like that, so I'm going to delete them. Actually, I'm going to delete the cube too. Classic start to a Blender tutorial. We're going to add in a plane here. I'm going to scale that up, I don't know, by 10 or something like that. It doesn't really matter. The only thing that really matters in general is making sure that when we look at this item that the scale has been applied, which is just like a general Blender tip. It's not specific to this project that we're doing. So I'm going to apply a material to this so that we can differentiate the objects in the scene. I'm just going to call that floor, set a base color of something that is, I don't know, maybe a dark blue. Maybe that's more of a purple, but that's fine. So we see something more like this. We're also going to add in a cube here. I'm going to do some scaling on this. So scale 0.5. I like having things scaled to like a 1 unit cube. Blender starts at 2 units. So we'll bring this up. I'm going to scale it on the y-axis. Blender has a different coordinate system. They are z up. Bevy is y up. So I think I'll scale that like this maybe. We don't really need to move it per se. But what I do want to do is I want to take these 2 vertices and move them down so that we end up with like a falling cubes kind of situation going on. Take these 2 vertices and just make it go up. And we'll end up sitting the camera over to the right here so that cubes kind of fall towards us like this. And that means that we'll want colliders on the plane, colliders on this like slope, and then the colliders on whatever boxes we're going to spawn in. So we'll throw another material on this and make it a slightly different color, maybe something a little bit more green. But again, these colors are just for differentiating each of the items. And then the other thing that I want to do, I'm going to add a second scene here. And this scene is going to be, we're just going to call this cube. I guess cube scene would be a reasonable thing to do here. We're going to have a cube inside of it. I'm going to scale that down to a unit sized cube again. Apply another material to it. Again, I'm just not going to name these, I don't think. Maybe we make this like a more cyan blue. And like we're going to want a collider on this. We're going to want a collider on the other things. But our first thing is going to be rendering the scene at all. So very first thing is we're going to save the .blend file here. I'm going to save that into a directory called art because that just tends to be where I save things that are art assets. I'll just save this as everything.blend. And now the other thing we need to do is export a gltf. In this case, we're just going to export everything, so we don't really need to check any boxes. We don't really need to do anything. But the one thing that I do want to do is make sure that we are putting this into the assets folder because that's where Bevy is going to look for it. I'm not entirely sure why that error popped up. Sometimes Blender just fails for whatever reason. So let's save that out. I think we got the gltf file that time. So the question becomes, how do we spawn this in at all, right? So we're going to create a startup function. We're going to add it to the startup schedule. We're going to want commands here so that we can actually spawn things into the world. We're going to want the asset server. And I think it's useful to point out how you would figure out what you need in the first place. So if you go into the Bevy GitHub repo and you go into the examples, in this case, in 3D, there will be something like load gltf, right? And this has a bunch of stuff in it. It has some lights and whatnot. Maybe we put lights in here, maybe we don't. I think since this is going to be using some of these things, that we will. So we're going to add this animate light direction thing too, just for kicks. I'm not going to care about things like changing the shadow config or anything like that. And I'm not going to care about the environment light because we don't have the map. And they called theirs setup, but I called mine startup. So I'm going to rename that. But you can see that it's the same kind of setup that we were going for. Mute commands, asset server. So in this case, we spawn in a camera 3D. That'll enable us to look at the scene. We spawn in a directional light that'll light some of the stuff. We don't really have anything too light per se, but we'll get a couple shadows here. And then this is the really interesting part here. They have a gltf that is called flight helmet. We have a gltf called everything.glb. So this is looking for scene 0 in everything.glb, pulling it in with the asset server, wrapping it in the scene root new type, and then spawning that entity. So that will spawn the entire scene. For us, if we want to figure out what's actually in this GLB, because the GLB is a binary file, not easy to read, VS Code will let you actually import this as a GLTF and then export it again. So you end up with this .bin, which we're not going to look at, and then this .gltf. And this .gltf shows you, here are the scenes. Scene 0 looks like it's actually cube scene. So we probably want scene 1 here since it's level 1. So we'll do scene 1 here. And we've got a couple of constants to pull in. So this is frac pi 4 from F32 constants, and then pi also comes from the same location. This is quite literally just animating the light direction. We don't strictly speaking need it. I think this is called animate light direction, right? We don't strictly speaking need it, but I think it's useful to have, so it'll be here moving that directional light. So we can see here that there's something spawning, but our camera is maybe not in the right place here. I think that's pretty much to be expected because we're kind of looking at something slightly different. So we probably don't want it to be up on the y-axis, maybe a 1 on the y, maybe a 0 on the z. And then we kind of get this angle looking up at this angle that we've set up. And you can play around with this, do whatever you want. I think maybe like -5 and 10 might be cool. And we're looking at something slightly over the exact midpoint. So we can see, more of the scene here. And if we make this bigger, it's the thing we had in Blender. Yay. As expected. So the next thing we want to do is actually spawn in the cubes, right? I think we'll create a new system for this. So like we'll spawn cubes and we're going to do basically this, but we're going to do scene 0 because that's going to be our cube. This is going to have to take the same kinds of things. And then we can do, if I can type correctly, we can do animate light direction and spawn cubes. And Bevy has this cool run condition called on timer. So we can pull that into scope. We can say every 1 second, we're going to spawn a cube in. And if we run this, then what we end up with here is our scene and nothing showing up. And that's because we didn't add any kind of transform here. So in this case, we want to probably do transform from XYZ. Let's do like 0, maybe 10. I didn't check how big the thing that we built in Blender was, so I don't know exactly what the right spot to place this cube is. But let's zoom out a little bit. Maybe zoomed out a little bit too far. So now we see that the cube is spawning above, but there's nothing happening. There's no gravity. There's no physics being introduced. There's nothing to see here effectively, right? So now we need to do physics stuff. And one of the things we could do is, add a collider to this scene specifically. And that would be fine. We're actually going to use Avian for our physics. And enabling that is pretty straightforward. We just need to take the physics plugins, which are going to come from Avian, and turn it on. And then like here, we could do a collider constructor, cuboid, and specify 1 and 1. And right up at the top here, I'm starting to pull some stuff in. So I'm just going to star in the prelude so that we have those Avian things in scope. And we run this, and now we see about every second a cube falls, and it just goes straight through our entire scene because nothing else has a collider, right? So Avian's taking care of dropping this cube for us, which is great. And like, yeah, it has a collider on it. Yeah, it's a rigid body dynamic. But the question becomes, how do we actually attach colliders to the things inside of this scene? So there are things we can do here in terms of like reaching in with code and specifying the collider that we want to actually show up on these things. So if we observe trigger, well, I need to write this in the correct way. Let's do observe, and let's say this is a function called onLevelSpawn. And then onLevelSpawn is a trigger for scene instance ready. So this is the event that will trigger when this scene spawns in and is ready. And from here, what I'm going to do is take a query for the children, or just all children, and I'm going to do trigger.entity in this case. This function specifically, entity, I believe got renamed. So if you're watching this in 0.16 or further, be careful of what you use here specifically. We want the entity that is the scene root. So if we take this children query, there's a function on it called iter_descendants. We can take that entity that is the scene root that we just spawned in, and we can just iterate through all the descendants, everything in the scene effectively, checking to see something. We're not checking to see anything currently, but we can at least run this and prove that this actually does run. So in this case, we end up with entity 18, 19, 20, 21, and 22. Now, we don't especially know what those are. One of the things you can do here is pull like a commands.entity.log components. So now our scene has spawned in and we see everything here. We see entity 18 has a transform, view visibility, it's got parent on it, it's got children on it, etc. We've got other ones with names. We've got a mesh 3D on one of the entities here and a mesh 3D on another one. So we also have these other like gltf material name and things like that. So we can do a check here just to give a vibe for what we're actually going to do to figure out where to add colliders. We can do a query for name, right? So anything that is an entity could potentially have a name. So in this case, I'm going to do like let okay name equals this, else continue. So if this has a name, give it to us and we'll debug it. If it doesn't have a name, then just continue the loop. We're only looking for things with names here. And then we get plane, cube, plane, and cube 1. So if we look at our scene here, we've got things plane, plane, cube, cube 1, right? So if I name this like plane mesh and like plane object, just to differentiate them a little bit when we're working with them, and we got, what did we call this? This is the incline mesh, we'll call it, and this is the incline object. And then we just don't get confused about what we're seeing here. We can just export this back to gltf, export, run this again, and those names are showing up here. So we know that we are spawning those objects in. So here we have options, right? We want to be able to get colliders onto these, and we want to do it in a way that is fairly generic, right? A way that we can define inside of Blender. This is where custom properties come in. So in this case, we're just going to put the custom properties on meshes. So if we go down to data here, and we go to custom properties on incline mesh, for example, then we hit new on custom properties. We can define anything we want here in this custom property. In this case, I'm probably just going to call it a string, and I'm going to call this like collider. Not going to have a default value, not going to have a description. And then this, I happen to know that try_mesh from mesh will work well for this. So I'm going to leave a string here that's called try_mesh from mesh, right? And then I'm going to leave the plane empty, right? So we're going to put this on one of the meshes. We're not going to put it on the other one. So let's export here. And the thing that we need to do here to get that custom property data is include custom properties, check this checkbox. Export this. And now the question becomes, instead of names, there's a component called gltf mesh extras, which comes from Bevy gltf. We'll pull that into scope, and this will become extras. You can see here, same logic, right? And we're just going to call this value, and we'll run this. And we should end up with one result here. So we haven't done anything with this data yet, but by putting data into that custom property, we're getting it in this gltf mesh extras value. So again, just to be clear, if we are on the incline object, and we go down to this mesh, this little green triangle. You can also do this for materials, which will also have custom properties, or the object itself, which will also have custom properties. But we're doing it on the mesh right now. So incline mesh, and we've specified try mesh from mesh as the collider, which is just a string. It's an arbitrary string. We could type in anything we want there. So here we get a JSON object with the value, and well, the key we defined and the value we defined, right? So key of collider, value of this string. Now you could do a number of things here. I'm going to pull in Serday JSON, and I'm going to pull in Serday with the derive. Again, we have Serday and Serday JSON here with the derive feature enabled. And I'm actually going to yoink some code from something I was working on earlier that inspired this. So we're going to use, I guess we don't need the vec3 here, right? So we've got Serday, deserialize, and serialize. This can go all the way up at the top, which is pretty typical. We can define some random struct called bmesh extras. Call this whatever you want. We have a field of collider and a value of this enum. In this case, it's going to be try mesh from mesh. That's just what I've decided. This is totally arbitrary. What isn't arbitrary is that we then get this value, right? And if we look at the log here, this is actually the gltf mesh extras. So we'll call this gltf mesh extras, which makes it a little bit clearer when we do .value here, because we are going to need to do Serday JSON from stir value. I'm just going to let data equal that. And this will be a result in this case. So you have some options here. It is quite common that there is metadata in these fields that you did not put there, because this is how Blender add-ons work. They stuff all of their stuff into these extras fields. So if you have a Blender add-on that's stuffing some additional data here, you could end up with something that didn't quite match up if you use key names that are too generic or etc. So namespace all of your data, you'll have less of an issue. And we'll type this from string as bmesh extras, which means this data is going to be a bmesh extra, and we'll debug this data. If I remember to put debug on all of the things that we want to actually debug. Turns out if you don't derive debug, then there is no debug representation. So in this case, I'm going to do another let OK, because I don't actually care about failures here, but you might want to do something else. You know, like maybe you say error, couldn't deserialize extras, something. I don't know. Doesn't matter. Not for us anyway. So we have a data, which is a bmesh extras now. We're debugging that out. Didn't want to add the Serday again. So if we run this, what we end up with is data of a bmesh extras collider. So if we then match on data.collider, we have that enum ready for us, ready to go. And we can commands.entity, the entity that we're working with, insert. And in this case, we're going to do probably a rigid body, static in this case. And we're going to use this collider constructor to do a try mesh from mesh. That's why I named it that. I just wanted to be clear about what I was trying to do. So now when we specify try mesh from mesh in Blender, this is going to recurse through everything that we've just spawned in our scene, look for anything with this component on it, look for anything with this particular value on it, and then insert the rigid bodies for us. So running this again, we see the cubes now start to pile up on the actual incline, which is great and very fun. So now we don't have colliders on the plane, right? So theoretically, if these get down far enough, then they will fall right through the plane like this one is about to. But again, we can fix that, right? We have the power to now go from here to our plane mesh. We're going to click on the mesh data here, make sure we're on plane mesh, add the custom property, use a string, call this collider, get that try mesh from mesh in here. We could, create other values here. Doesn't need to be this. And then export this gltf, make sure that the custom properties data is coming with it. And then our gltf is already set up, right? So if we go back and we watch this again, then I expect vaguely the same thing to happen. But yeah, now our plane actually has a collider. So the ones that are falling off the front are not actually falling through that plane. And we've defined this through custom properties inside of Blender, which is really cool. And these will just keep piling up because, it's avian and physics and colliders. And we can do the same thing for pretty much anything, right? So one of the things that we could do earlier, I had something in here called like cube size, right? And this was a vec3. And at this point, we kind of have to be careful about matching up to make sure that the way that we represent data or want to represent data in Blender and the way that we want to represent data in our serialization match up. So in this case, I'm just going to have a cube size here, but it's going to be an option. So it doesn't have to exist. And then let's take this collider constructor off, right? Maybe we also take rigid body dynamic off. I'm going to call this B rigid body. And we're only going to have two things, right? Static and dynamic in our case. So if we're adding colliders here, we could say rigid body as well. And this is always going to be here for us. So I guess we'll just do be rigid body. So now we have to have collider. We have to have rigid body for this to be successfully handled. Again, we are just skipping anything that we can't parse. So in this case, anything that's written in a custom property that doesn't parse correctly, doesn't crash our application or anything like that, we just won't get a collider. And that's where add-ons start to come in, right? You can see how this would get pretty complicated, adding gltf extras data all over the place in different ways. You saw that as we did that inside of Blender, we kind of had to define the field over and over, which is, human has to remember to spell thing correctly is not a good assumption. So building an add-on, having a UI, something more like Blenvy, is actually very useful. But we can continue to do this in here, right? String, rigid body, and this one is going to be static because it's our plane mesh. And I'm going to go up to our incline mesh here, add another custom property, string, rigid body, static, save that out, export this as gltf. Now we should be able to get this data. So let's keep our debug here for this data. And for our data, we get try-mesh from mesh static for both of them, which is great. That's what we were looking for. So now, instead of having rigid body static here, we can have match data dot rigid body. And for here, we're just going to do rigid body dynamic, rigid body static, right? So all we have here is static for each of these try-meshes, which is fine. All of this should still work, except for the fact that when we think about spawn cubes, we're spawning a cube without anything on it, potentially. So if we want to handle this as well for our cubes, we have this on level spawn. Maybe we don't say on level. Maybe this is on scene spawn or attach colliders or something like that. So now we've got observe on scene spawn for the level that we're loading. And we can also go to spawn cubes, spawn on this scene route, on scene spawn here as well. We could also listen to this globally, anything that we spawned in, right? In this case, I'm happening to do it locally, but observers are both local and or global. So our cube's still hanging out up there, which means that we don't really have our data in place. So let's go over to cube, cube 1 in this case. Cube 2 is the mesh inside of it. Make sure we're on cube 2. We'll add a collider, and I guess we can try mesh from mesh this as well. Doesn't really matter that much. And we can also do our rigid body type, which will be dynamic, and we can export this as a gltf, make sure our data, custom properties, is being exported, run this, and then we get dynamic cubes, and we're defining what kinds of colliders need to be attached to these meshes inside of Blender. So maybe we do this and we decide that, hey, these are cubes. We don't really need to do like a full tri-mesh from mesh type of collider. We know it's going to be a cube. We know the size it's going to be. We can just set that up. That's why we did cube size here. So we can now do cuboid in our enum. Of course, now that we have cuboid, we have to actually use it. So now when we get a collider that is a cuboid, we can decide exactly what to do. And in this case, we're going to stick with our little static dynamic here. And you can see that this is maybe getting a little bit repetitive if we're going to do a bunch of different colliders. So maybe this gets pulled out into, a separate thing, etc. But we can do a collider constructor cuboid, or we can do a collider cuboid. And for now, I'm just going to do data.cube size, assuming that, and I'll expect here, cuboid collider must have cube size, let's say, right? So now we've got a vec3 here. If you specify cuboid, then you also have to specify cube size, and this will go size.xyz. And let's throw in the physics debug plugin, and let's move the camera a little bit closer. So this is what we already would have had, right? This is the tri-mesh version because we haven't changed anything. So you can start to see some of the actual colliders in here and what they look like. All of these orange lines are the physics debug. And then if we go over here and we change the collider to a cuboid, this should now actually break, right? So just to prove that it will actually break, let's run it with the new data. When we spawn in, we say, oh, cuboid collider has to have cube size. We chose to make that break, and it did. So we're going to choose a float array here, and this is going to be cube size. It's going to be an array length of 3. We're going to set some defaults here. It doesn't really matter. So we get a 111 cube size out of this. Export that data again to the gltf, rerun our program, which we haven't modified the actual code here. And then we get something that looks a little bit different. So instead of tri-meshes, instead of something that matches the mesh, we're getting literal cubes as the colliders here. And you can see that without the little slashes in them, right? So not everything is fit for tri-mesh from mesh, you know. My understanding anyway is that it's a little bit more performance expensive to do that kind of collider, whereas a cube is a very defined thing. But that's not really the point. The point is that we can actually do any kind of collider we want, any rigid body. We can put any data into these custom properties that we want, right? Collider, cuboid, cube size, rigid body. Now, hangups. One really interesting thing here is that if this was in a collection, you know, it's in this scene collection right now, but all collections, if we did like a new collection here and wanted to move it inside like this, the collections disappear. So while you can go in here and go to this object and click on this collection, right? So we're in collection now and scroll down and there's custom properties here on that collection. These custom properties, if you're on a collection, because the collection doesn't get exported into the gltf as a node or anything, it just gets dropped entirely, you will not see any custom properties that you specify on a collection. So there are certain things for which the gltf extras don't make it through gltf. Like if you put the custom properties on a collection, for example, it should work on meshes, it should work on objects, it should work on materials, things like that. But collections are really the big call out here. So that's it. This is our scene. All the colliders are specified inside of Blender using custom properties. We use gltf extras to actually pull that in. The cubes are dynamic. They use a cube collider. The plane and the incline that we have here use tri-mesh colliders. We probably would want to extend maybe the plane to be a half space or something like that. So if you want to go play with it, maybe try to do that. One last thing I want to show is specifically in examples in the Bevy repo in 3D, there isn't just a load gltf, but there's also a load gltf extras. So if you try to put custom properties on something, you're not sure where they are, there are a number of different places those extras can be. For example, on a scene, on a mesh, on a material, etc. So it may be in one of these other components that isn't necessarily the gltf mesh extras that we were just using, but same idea for all of them. And the nice thing is actually that you can kind of use this as a debug program. So this load gltf extras, if you have your gltf, you can just change this import and start dumping out any of the extras that are in your gltf export. So you can actually just do a check to make sure that you're doing this in a way that the gltf actually has data. But that's it. So I hope you enjoyed it. And if you have any questions, as always, leave them in the comments and I'll see you in the next one. Have a great rest of your day.